In-office modification of rigid lenses enables any contact lens practice to increase efficiency and provides a valuable service to the patient. This program features RGP modification procedures. The following techniques are easily acquired through practice and can give you optimum control over the lens fit as well as save time for you and your patient. The modification categories presented in this program are secondary and peripheral curve fabrication, edge polishing, surface polishing, and lens repowering. Before performing modification procedures, it's important to establish objectives. In our example, the goal is to modify a monocurve into a tri-curve lens. The monocurve has a 7.8 millimeter base curve. In the steps to follow, a 9 millimeter secondary curve along with an 11.2 peripheral curve will be added to achieve our goal. Always begin by obtaining baseline data. Our first lens, measured in a radioscope, is confirmed to have a 7.8 millimeter base curve. The structural and surface qualities of a lens are easily verified using a projection magnifier. Evaluation reveals a monocurve or single curve lens with no junctions or light reflex changes across the surface. To apply secondary and peripheral curves, diamond, Delrin, or brass radius tools can be used. Delrin is recommended for superpermeable RGP materials to minimize heat transfer. In this procedure, brass tools are used. For adding the 9 millimeter secondary curve, select an 8.8 millimeter radius tool and smoothly apply a square of waterproof adhesive tape to the surface. The tape is approximately 0.2 millimeters thick. When added to the tool, the combined curve radius measurement equals the desired 9 millimeters. Softer Pellon or velveteen pads can be used in place of adhesive tape. Mount the tool on the spindle. To begin, moisten the suction cup with water. Mount the lens centered with the concave surface facing outward. Centering the lens on the cup is very important to ensure proper modification results. Failure to do so results in a decentered optical zone and uneven edge thickness. Note proper hand position. This, along with minimal pressure, allows for maximum control during the modification process. Turn on the modification unit. Apply polish to the surface of the tool. Vertically position the lens lightly against the rotating tool. Using a figure 8 pattern, rotate the lens slowly and evenly in the opposite direction of spindle rotation. Lift the lens away from the tool every 5 to 10 seconds. Continue to apply polish. Insufficient polish, as well as excessive hand pressure, can lead to heat buildup and lens damage. Evaluation with a projection magnifier reveals a bicurve lens. Note distinct light reflex changes at the junction between the base and secondary curve. For adding the peripheral curve, select an 11 millimeter brass radius tool and apply adhesive tape. The tape, added to the tool, equals the desired 11.2 millimeter curve radius needed. Once again, apply polish. Vertically position the lens lightly against the rotating tool. Using a figure 8 pattern, rotate the lens slowly and evenly. Projection magnifier evaluation reveals an unblended tri-curve lens. The light reflex changes at the sharp junctions between the base, secondary, and peripheral curves. Unless blended, these ridges can inhibit tear exchange and possibly cause epithelial erosion. Blending and polishing smooth the junctions between the curves. This increases lens movement, comfort, and tear exchange. This procedure is accomplished by using a series of radius tools. For blending and polishing the base curve secondary curve junction, select a radius tool halfway between the base curve and secondary curve radius, allowing compensation for pad thickness. For the secondary curve peripheral curve junction, select a tool halfway between the radius values of both curves. For the final blending polishing process, select a tool halfway between the secondary curve and peripheral curve radius. For all blending procedures, once again compensation for pad thickness must be made. If, for example, velveteen is used, it has a thickness equal to about 0.4 millimeters. The methods for blending are similar to those used for applying secondary and peripheral curves. Only a gentle touch is required to obtain the desired blend. Results are determined by the blend time, lens material, and type of polish. Again, observe the sharp junctions between the base, secondary, and peripheral curves. A light blend is achieved after a few seconds of blending. The transition zones are still easily observable. About 10 seconds are required for a medium blend. The curve junctions are less distinct. After 20 seconds, a heavy blend blurs but does not totally remove the transition zone. There are alternative methods for applying peripheral curves. The first is using a suction cup held at a 30-degree angle from vertical. The entire outer lens edge should maintain contact with the covered tool at all times. To avoid a decentered optical zone, rotate the lens opposite tool rotation at least one full turn. A spinner may also be used for peripheral curve application. The lens, centered on the spinner, is held at a 45 to 60-degree angle from vertical. This positions the lens slightly off-center from the apex of the radius tool. Keep the spinner spinning at all times. Recommendations for peripheral curve application include use of a liberal amount of polish, a variable speed modification unit at slow RPM, and even, though minimal, hand pressure. Excessive hand pressure can distort and ruin the lens during modification. After blending and polishing the secondary and peripheral curves, confirm the surface quality of the lens with a reticle magnifier or biomicroscope. The shape and quality of an edge is important for providing the patient a comfortable and well-centered fit. A projection magnifier is used for precise evaluation. The edge should be observed frontally and in profile. A good edge presents a smooth, rounded tip with a centered apex. A sharp edge has a pointed tip. Polishing smooths and rounds the apex. A frayed edge can also be smoothed and tapered by polishing. If microchips are present, discard the lens and reorder. A blunt edge must be reshaped first, then polished. The Edge Profile Analyzer, used in combination with the radioscope, also allows for direct inspection of any contact lens edge profile. There are several methods for shaping and polishing the lens edge. An interior or CN bevel may be added to the lens to reduce a thick or blunt edge. It's also beneficial for lowering a high-fitting lens. A 90-degree cone tool is most often used to create a CN bevel, although a 60 or a 120-degree tool can also be used. A pre-cut velveteen pad is placed so that it conforms to the cone surface. The lens, centered on a suction cup convex side out, is placed in the cone and gently rocked back and forth, left and right. The rocking motion creates a smoother transition zone on the anterior surface. Too much rocking motion can cause optical distortion. After the bevel is applied, polish the edge thoroughly. A sponge tool is very effective for routine polishing and slight shaping of the lens edge. The sponge is thoroughly moistened with water and mounted on the spindle. The lens is mounted on a suction cup concave side out. Apply polish to the sponge and vertically motion the lens up and down into the center of the tool for 30 to 60 seconds. A flat sponge tool can also be used for edge polishing. The lens is attached to a spinner, concave side out. While applying polish, move the lens side to side, maintaining contact with the sponge. To obtain a smooth edge, it may take approximately 30 seconds, depending upon the condition of the original edge. Surface polishing is one of the most useful and common modification procedures performed in the office. Using proper technique, scratches are easily removed from the lens while maintaining the optical quality. Wet the sponge tool and mount it on the spindle. For polishing the front surface, center the lens on a suction cup, convex side out. Apply polish and position the lens at a 45-degree angle, halfway between the center and edge of the sponge. Rotate the cup in a direction opposite the tool rotation. The lens is depressed into the sponge about 1/8 of an inch for about 10 to 15 seconds.
To polish the center, hold the lens perpendicular to the center of the sponge. Vertically motion up and down 10 to 12 times. Contacting the sponge at 1-second intervals minimizes optical distortion or power changes.
Check for remaining surface scratches every 20 to 30 seconds with a projection magnifier, and verify the power with a lensometer. There are alternative front surface polishing methods. Light scratches and surface deposits can be removed by simple hand polishing. Polish pads provide a soft, sponge-like surface for this technique.
A hollow velveteen-covered tool is also utilized for front surface polishing. The lens is centered on a suction cup, convex side out. A liberal amount of polish with light hand pressure is used in combination with plenty of cup motion for 15 to 30 seconds.
For polishing the back surface, a cone sponge tool is pre-moistened with water and placed on the spindle. The lens is mounted on a suction cup, concave side out. With vertical motion up and down, rotate the lens opposite the spindle rotation for about 10 to 15 seconds. The lens is depressed into the sponge about 1/8 of an inch. Repeat if necessary after inspection. A significant advantage to fitting RGPs is the ability to modify the power of a lens in the office. Use of a wet toe pad is used to add minus power. The toe pad is mounted on the spindle with good vertical alignment. The spinner, with the lens-centered convex side out, is positioned perpendicular to the toe pad surface, approximately 1.5 centimeters from the apex.
The amount of minus power added depends on hand pressure, time, and compounds used. As much as 1 diopter can be added without distorting the lens optics. The power should be evaluated every 10 to 15 seconds with a lensometer. Use of a flat sponge is another effective way to add minus power. The lens, centered on a suction cup convex side out, is positioned halfway between the center and the edge of the sponge. Barely touching the surface, the lens is held perpendicular to the tool surface and is rotated opposite spindle rotation. Approximately 4 revolutions equals a change of 1/4 diopter. The limit for adding minus power to a spherical lens while still maintaining optical quality is about 1/2 a diopter. A hollow velveteen-covered tool is also utilized for adding plus power. The lens is centered on a suction cup, convex side out. A liberal amount of polish is used along with light hand pressure. The technique differs from front surface polishing in that cup motion is minimal and duration is longer for adding plus power. Usually no more than 1/2 a diopter is attempted. Adding plus is more difficult than adding minus.
The spinner and toe pad combination may also be used to increase plus power. The angle of the spinner should be adjusted until 1/2 to 1/3 of the lens is in contact with the toe pad. Plus power is added as material is removed from the periphery of the lens rather than the center.
Careful monitoring of edge thickness is recommended while adding plus power, as the edge can be thinned using this procedure.
In-office modification of rigid lenses enables any contact lens practice to increase efficiency and provides a valuable service to the patient. Acquiring these skills can help you be successful in the art of rigid lens fitting, giving you optimum control over the lens fit, as well as saving time for you and your patient.